Hey everyone, and welcome to another deep dive. This time we're going to be talking about something really cool, AI memory. Basically how researchers are trying to give AI the ability to remember, just like you and I can. And why is this so important? Well, it could completely change how AI interacts with the world and how we interact with AI in the future. So to help unpack all of this, we're going to be taking a deep dive into some insights from a video by an expert in the field, Adam Lusk, and he explores different types of memory for AI agents.
Yeah, this is a really exciting area because for a long time, AI, particularly language models like the ones that power chatbots, they haven't really been able to retain information from past conversations. They've essentially been stateless.
Stateless. So is that kind of like having a friend that
Yeah.
every time you start a new conversation with them, they forget everything you've ever told them?
Yeah, exactly. Each interaction is like a blank slate. Imagine how frustrating that would be. You constantly have to reintroduce yourself or repeat all your preferences every time you chat with your AI assistant.
Oh yeah, I can see how that would get old pretty quick. So I guess building memory systems for AI is a pretty big deal, huh?
Absolutely. And to tackle this, researchers are actually drawing inspiration from human cognitive psychology. They're exploring how to equip AI with four key types of memory: working memory, episodic memory, semantic memory, and procedural memory.
Four types of memory. I'm already intrigued. Uh, Maybe we could start with working memory. What exactly is that?
Sure, so working memory, you can think of it as the AI's short-term memory. It's what allows it to keep track of the immediate conversation, the context, and what's been said recently.
Okay, so like a mental notepad for the current conversation.
Exactly. It's kind of like juggling. The AI has to keep all the relevant bits of information in the air at the same time so it can follow along and respond coherently.
So without working memory, the AI couldn't even follow a simple conversation.
That's right. It's a really fundamental building block for any meaningful communication.
Yeah, that makes sense. What about episodic memory? I think I've heard that term before. Does that have something to do with learning?
You're exactly right. Episodic memory is like the AI's personal scrapbook of experiences. It's a collection of memories from past interactions, similar to how we humans store memories of events in our own lives.
Oh, so it's not just remembering what was said like 2 seconds ago. It's also remembering conversations from maybe last week or even last month.
Exactly. And this is where it gets really interesting. Episodic memory allows the AI to actually learn from those past interactions, identify patterns, and even personalize its responses based on those experiences.
So it's almost like the AI is developing a sense of history and context for each user, making it feel less like talking to a machine and more like talking to someone who actually knows you.
Exactly. It's about moving beyond just those simple question and answer interactions and building a more nuanced understanding of the user over time.
Gotcha. So we've got working memory for like the immediate context and then episodic memory for the AI's personal history.
Yeah.
What about semantic memory? How does that fit into all of this?
Semantic memory is basically the AI's vast knowledge base. It's the repository of facts, concepts, and relationships that the AI knows about the world. Think of it like a massive encyclopedia that the AI can tap into to provide accurate and informative answers.
So episodic memory is about remembering personal interactions. And then semantic memory is more about connecting to a wider world of information.
Yeah, that's a great way to put it. It's like the difference between remembering a specific conversation you had with a friend about the Eiffel Tower versus knowing just general facts about the Eiffel Tower, its height, location, history, those sorts of things. Both are important, but they serve different purposes.
Okay. I'm starting to see how this all fits together. One more type of memory, though, right? Procedural memory.
Right, procedural memory.
What does that one do?
That's all about remembering how to do things. It's the AI's ingrained habits and routines, shaped by both its programming and its experiences.
So if semantic memory is knowing what things are, procedural memory is knowing how to do things, like knowing the rules of a game versus actually knowing how to play it.
Exactly. It's the difference between knowing that a bike has two wheels and pedals and actually knowing how to ride a bike.
So this is where the AI learns to, like, follow instructions or complete tasks.
Exactly. Think about how you've probably taught your smartphone's virtual assistant to do specific tasks, like setting alarms or sending texts. That's procedural memory in action.
Wow. I'm starting to see how all these different types of memory can really work together to create a much more intelligent and responsive AI. Each one seems to play a really crucial role in shaping how the AI perceives and interacts with the world.
Absolutely. And as we go a little bit deeper, we'll uncover even more fascinating details about how these memory systems are combined to create truly remarkable AI
Okay,
capabilities.
this is already blowing my mind. Can't wait to hear more.
So let's move on to how these memory types interact and learn from each other.
All right, sounds good. Let's dive in.
So welcome back. Let's dive a bit deeper into how these different memory systems can actually interact and influence each other in AI.
Yeah, I was thinking about this, and I'm curious, like, how are these memories actually stored? Is it like a giant file cabinet in the AI's brain?
Uh-huh. Well, it's a fun image, but it's a little bit more nuanced than a simple file cabinet. AI researchers are actually using something called vector databases to store and organize these memories.
Vector databases. Okay. Can you explain that a little bit more?
Sure, so imagine a library, but instead of organizing books by genre or author, you arrange them based on their meaning. So all the books about history would be clustered together, regardless of their author or publication date.
So like grouping books by their core concepts, even if they use different words or writing styles.
Exactly. That's the beauty of vector databases. They allow AI to store and retrieve information based on its semantic meaning, not just its literal form. So think about it this way. If you tell your AI about a funny experience you had on vacation, it can connect that story to other memories about vacations, or humor, or specific locations, even if you didn't explicitly mention those things.
Wow, that's pretty incredible. So it's like the AI is building this whole web of connections between different memories, allowing it to access and retrieve information in a way that's much more flexible than just simple keyword searches.
Exactly. It's
Yeah.
about understanding the meaning behind the information rather than just the words themselves. And
Yes.
this leads to some really fascinating capabilities, like the ability for AI to actually reflect on its past experiences.
Reflect, like sit back and ponder the meaning of its digital life.
Haha, maybe not quite that deep. But the principle is similar. Researchers are developing techniques to help AI analyze past conversations, identify patterns, and even generate summaries of key takeaways. Imagine having a conversation with your AI assistant about a recent trip, and afterwards it generates a concise summary. Something like, user enjoyed exploring local cuisine but experienced some difficulties with transportation.
Okay, that is super helpful. It's like having an AI travel companion that actually learns from your experiences and
Mhm.
becomes more helpful with each interaction.
Exactly. And this reflective capability isn't just limited to conversations. AI is learning to reflect on its performance in more complex tasks too, like playing games or even controlling robots. Imagine an AI that plays a game of chess and then analyzes its moves afterwards to identify weaknesses and improve its strategy for the next game.
Whoa, so it's like the AI is becoming its own coach, constantly evaluating its performance and trying to get better.
Yeah, it's a fascinating idea, isn't it? This ability to learn and adapt is what really separates truly intelligent AI from just simple rule-based systems. And it's all made possible by these advances in memory systems.
So it seems like we're moving away from this idea of AI as a simple tool and towards a future where AI is more like a collaborative partner, capable of learning, adapting, and even contributing to problem solving in a much more meaningful way.
That's a great point, and it raises an interesting question. How does AI actually use all this stored information and reflective capability in real-time interactions? How does it decide which memories are relevant and how to apply them to the current situation?
Yeah, that's a good question. It seems like a pretty complex process. It's almost like having a whole team of memory experts working behind the scenes, constantly evaluating the situation and pulling the most relevant information to guide the AI's response.
Yeah, that's a great analogy. It does involve a lot of intricate computation,
hmm
weighing different factors, and even predicting what information might be most useful in the future.
It's like trying to predict the future
Yeah.
while simultaneously remembering the past. No wonder this is such a challenging area of research.
It definitely is. But researchers are making incredible progress. They're developing these really sophisticated algorithms that allow AI to seamlessly integrate all these different memory systems and dynamically access the information it needs at the right time.
So are we talking about AI that can like engage in even more nuanced and sophisticated conversations?
Mhm.
AI that can understand things like humor or empathy, or even generate creative text formats?
Absolutely. We're already seeing AI systems that can do all of those things. Take, for example, the emergence of AI that can understand humor. This goes far beyond just recognizing a simple pun. It involves understanding context, social cues, even the subtle art of timing. And it's all made possible by these advances in AI memory.
This is all incredibly fascinating, but it also makes me wonder, What are some of the limitations of current AI memory systems? Are there any challenges that researchers are still grappling with?
Yeah, that's a great question. And it leads us to some of the frontiers of AI memory research. There are indeed some significant challenges to overcome before we can fully realize the potential of AI memory.
Okay, I'm ready to hear about those. What are those cutting-edge researchers up against? Welcome back to the show.
So we've been talking about all this amazing potential of AI memory, but you mentioned there are some challenges too. What are some of the things that researchers are still trying to figure out? Well, one of the biggest hurdles is scalability. We can build AI systems with impressive memory capacity, but they often require enormous computing power and storage. It's kind of like trying to squeeze the entire Library of Congress into a shoebox.
Oh, wow, I see what you mean. So not exactly something we can easily run on our laptops or smartphones.
Exactly. That's why researchers are working hard to make AI memory systems more efficient and more compact. Imagine a future where your AI assistant can seamlessly access and process huge amounts of information without draining your phone's battery in like 5 minutes.
Yeah, that would be amazing.
Yeah.
So scalability is one challenge. What else are researchers working on?
Another big one is robustness. Human memory is actually surprisingly resilient. We can recall events even with incomplete or fuzzy details. But current AI memory systems can be pretty fragile. Even small errors or inconsistencies in the data can throw them off.
Yeah, so it's like the AI's memories are stored on a bunch of old floppy disks, just waiting to get corrupted or lose data.
Haha, yeah, something like that. So researchers are trying to make AI memory more robust, able to handle noisy or incomplete information without losing accuracy. Think about how you can still understand a friend's story, even if they jump around in the timeline or leave out some details. AI needs to be able to do that too.
Yeah, that makes sense. We want AI to be reliable, right? Not just suddenly have a memory glitch in the middle of a conversation.
Yeah.
Anything else?
Yeah, one more challenge I'd mention is adaptability. Human memory is constantly evolving. We learn new things, we update our understanding of the world, and we even forget information that's no longer relevant. Current AI memory systems aren't quite as good at this dynamic adaptation.
So it's like the AI's memory is this cluttered attic, full of outdated information, and it's hard to find what's actually useful.
That's a great way to put it. So researchers are exploring ways to give AI the ability to manage its own memory more effectively. Imagine an AI that can prioritize important information, update outdated memories, and even forget things that are no longer relevant.
So we're talking about AI that can not only remember, but also learn how to learn more effectively, becoming more intelligent and adaptable over time.
Exactly. This kind of dynamic memory management is really crucial for creating AI that can truly thrive in a complex and ever-changing world.
Wow. This has been a really fascinating deep dive. It feels like we've only just scratched the surface of what's possible with AI memory.
Yeah, I think that's true. But the progress we've made, even in just the last few years, is pretty remarkable. And with all this ongoing research, we're getting closer and closer to a future where AI can not only remember, but also truly understand, learn, and even reason in ways that were once thought to be solely human capabilities.
Yeah, that's both exciting and a little bit intimidating, I have to say. So what are some of the real-world applications of all of this?
Well, the possibilities are vast. Think about personalized AI assistants that can truly anticipate your needs, help you manage your time more effectively, or even guide you in learning new skills.
So it's not just about retrieving information, it's about AI that can actually become partners in our daily lives.
Exactly, helping us achieve our goals and live more fulfilling lives. And beyond just those personal applications, imagine AI that can help us solve big global challenges, like developing new medical treatments, designing sustainable energy solutions, or even fostering better communication and understanding across cultures.
It sounds like AI memory is more than just a cool new technology. It's like a fundamental shift in how we think about intelligence
Yeah.
and the future of human-machine collaboration.
I completely agree. We really are on the cusp of a new era where AI powered by these advanced memory systems will play an increasingly important role in shaping our world.
That's a really inspiring thought, and I'm sure our listeners are eager to learn more about all this. So if you want to dive even deeper into this fascinating field, we highly recommend checking out the full video by Adam Lusk. We'll be sure to include a link in the show notes. And for those of you who are interested in understanding how all these developments can actually be applied to your work, you can reach out to the experts at Shogini for personalized training and consulting. You can find them at https://www.sogini.com.
That's right. Keep exploring, keep learning, and keep those curiosity circuits firing.
I love it. That's a perfect note to end on. Thanks for joining us in this incredible journey into the world of AI memory. Until next time, stay curious.